Knowing this 2x2 confusion matrix is just the beginning. There are many different metrics can be derived from those basic metrics. In particular, many metrics can be derived by taking ratios of different numbers from this basic metrics. First, let's introduce a set of metrics that are derived by normalizing some terms with the ground truth value, either the total population, or the condition positive, or the condition negative. All these metrics are defined by some conative divided by those normalization terms. For example, accuracy is the ratio from the sum of true positive and true negative divided by the total population. Accuracy is the most basic metric that many people have intuitive understanding, but accuracy is not always the best measure when the class label are very imbalanced. If only 1% of the total population have heart failure, models can be achieved 99% accuracy by simply predicting everyone would not have heart failure. So, it is important to use the appropriate metric for measuring the performance of a predictive model. Another important metric is true positive rate, or sensitivity, or recall. They have different names because the same metric has been developed by different communities, and true positive rate equals the true positive divided by the condition positive and the ground truth. To explain the intuition, let's assume positive means heart failure and negative means without heart failure. The intuition of true positive rate is to measure among all people with heart failure what percentage is correctly identified by the predictive model. A very related metric can be derived called false negative rate, which equals 1 minus true positive rate. The intuition of false negative rate is among all heart failure patients, what percentage of those patients is missed by the predicting model. False positive rate is the ratio between false positive and the condition negative. The intuition of false positive rate is to measure among all people without heart failure, what percentage of them is incorrectly predicted by the model as to have heart failure. Finally, true negative rate or specificity is the number of true negative divided by the ground truth condition negative, which also equals 1 minus false positive rate. The intuition behind true negative rate is to find among all people without heart failure, what percentage of them is correctly classified as non-heart failure patients. Note that accuracy measures the combination performance of true positive and true negative, while true positive rate measures the performance only about true positive, and true negative rate measures the performance only about true negative. It is often possible to obtain high performance on a single metric such as accuracy, while it's difficult to obtain high performance on all metrics. That's why we often test a predictive model against multiple metrics. First of all, different metrics are designed for different situations. It is important to choose the proper metric for your prediction study.